Now let's say we have a right angle triangle, point A, point B. And this is 90 degrees right here, right? And this is going to be 30 degrees here. This is point C. So we have 30, this is 90, all right? And of course this would have to be 60 here. Let's say we want to construct this angle, right angle triangle. Then what we do, let's get line AB. Of course, we'll put the measurement there. So let's say this is actually 6 centimeters. So I'm going to draw that line first off. Now, I don't have to draw it as 6 centimeters. I can draw it longer than 6 centimeters, which is a good idea first of all. All right, and then, so this line is longer than 6 centimeters. Why I do that? Because I want to go in a little bit on the line so I can actually make an angle there. So it's important not to start at the edge. Get a little space here. And I want B to be somewhere here, so I get a little space there as well. You'll see why. So what I'm going to do now, I'm going to, let's say, center this is my compass, by the way. And any distance I open it to is called a radius distance. So this will always be the center. Remember, when I construct a circle, right, the line drawn is the circumference, and this will be at the center of the circumference, a center of the circle I should say. And so from the center to the circumference will be my radius distance. So now I have this line drawn. I want to go here, right? I want to go here. For instance, I can start here. I remember, so I want to have a space there. And I can measure off. So let me line up that ruler with this line that I drew earlier. So that I can measure off 6 centimeters, right? 6 centimeters we want? Yes. So I want to make sure that it's exactly 6 centimeters. I want to go a little bit more. Alright, so that looks like 6 centimeters. Good. So I'll keep it there and I'll just scribe an arc to cut this line. Alright, it's important that you tighten your compass. You can use a knife and make sure it's tightened. It's not too tight, by the way. You can actually open it easily, but not too slack so that it changes the radius distance. So I'm going to go where the arc intersect the straight line, and ensure your arcs are visible, right? Construction line should be shown clearly. So I'm going to go where the arc meets this line, ensure the point is actually there to be as accurate as possible. And I'm going to scrub an arc at the other end. Now where I scrubbed the arc is actually where I was coming from, and you can always double check that. Let's see. When I go here, you see where it actually cuts? Same place. So this will be point A, and this will be point B. Now I want to create a 90-degree angle at B. So what I'll do, I can change the radius distance to create a nice little semicircle. So the semicircle will cut this straight line here to the left of B and also to the right of B. Right? In fact, I could have just simply cut here a little bit. I didn't have to show this line going all the way around. I could just simply make the arc cut here and then put it around here and make the arc cut here. But what I want to do next is to go at both ends where the arc intersect the straight line. So it intersects the straight line here. So I'll go here. And I want to make sure that my compass is open more than half of the length of B, so that when I scrub an arc, when I go to the other end of the intersection, when I scrub the arc, they actually will cut each other. They actually meet there. Okay, so next I will draw a line through the intersection of the arc here, and to the point B. Okay, so I'm going to do that now. I'm going to draw a line here. Okay. Now if I measure this is my zero line on this is my protractor, by the way, and this line is my zero line. This is center of the protractor. So I'm going to put the center of the protractor at the center, right where B is at. and this line will be on this line. Just that now. I call this my 0 line. So make sure it's aligned in both places. So at this end, 0, at this end, it's aligned as well. So if I go all the way around, 10, 20, 30, 40, 50, 60, 70, 80, 90, you can see that it's actually 90 degrees. Okay, so this is 90 degrees to this point, and this is also 90 degrees. So I created my 90-degree angle here. Good. Now I want at this end to create what? 30 degrees. Now to create 30 degrees, what I'll do, I'll create 60 first. In fact, let me create the same 180. Then I'm going to bisect, well, I'm going to not bisect, I'm going to create the 180, and I'm going to form the 60, and then bisect the 60 to get 30. Yeah, let's do that now. So I'm going to basically, well, this little outer part is kind of small, so I'm going to just make sure that I get an arc to still be on the line. Just gonna put it in a little bit. Yeah, I made a nice little arc here, or semicircle. So any part of a circumference is called an arc, right? So where the arc intersects here and on here. All right. In fact, let me just go here, because once I'm there, I can create a 60-degree angle. So let's go over what we did here. Semicircle, but I'm gonna go at this end only. You'll see why. Which is the intersection, right, of this straight line and the arc. Go at the intersection and scribe an arc here. Let me just double check to ensure that I didn't change the radius distance. No, I didn't. Let me go here. Alright, and so what I'm going to do, where they intersect, that will be 60 degrees. So I'm going to draw a line from the center here at A. When I say 60 degrees, I mean for the line I'm going to draw, it will be 60 degrees to this line. Look, I'm going to go to the intersection and draw a line through A and through that point there. So let's do that now. Now, by the way, we don't want 60 degrees because it's not 60, it's actually 30. So what can I do? Okay, so what I can do perhaps is to draw, the 60 like that, but I don't want 60. I actually want what? 30. So now this is actually 60 degrees. All right, we can actually measure it and see. All right, so you can clearly see that this line is at what? 60, right? So I hit it at 60, from 0 to 60. See? That's the line. Okay, but I want 30 degrees. So what I'll do, I'll need to bisect this 60-degree angle. How do I bisect an angle though? So this is one leg of the angle, this is another leg of the angle. How do we bisect this angle? Well, what I need to do is have a line, an arc that cuts both legs. And we can actually use this arc already. Right, so this arc here cuts this line and this one. So we can go at both ends. And let me scribe an arc here. Right, so I go at this, where the arc meets this leg of the angle. I scribe an arc. I'm going to go at the other intersection of the arc, this arc here, and this straight line, which is right here. And scribe an arc as well. And where they intersect, I'm going to draw a line through A. And what that does, it'll actually bisect this 60-degree angle. Bisect means cut it in two parts, giving me 30 degrees on either side. So this will happen. What will happen here now is that this will be, alright, so we can clearly see that this is going to be our 30-degree angle. We can always double check it to see how accurate it is. And as you can see, this is 0, and going up will meet 30. Alright, 10, 20, 30. So this angle here is 30 degrees. So it's 90. Alright, so we have constructed, oh by the way, where this line meets this one is point C. So we have constructed this shape. Alright, now what's the length of this? What's the length of this side? No, this is actually 6, so we should actually put that in. 6 centimeters from A to B. Put it at the center. What's the length of this? Can we find it out by using a ruler? Of course. Simply go here and measure, and I get approximately 3.5 centimeters for BC. So if you're asked to measure BC, measure it and I got 3.5. How accurate is that though? Well, we can check how accurate it is. Remember, you're going to be off when using the ruler and protractor and all of that, but we can actually use trigonometry to get the exact measurement, right? But in construction, they wouldn't ask you to do that, right? They wouldn't ask you to do that. Well, unlikely. They could, but very unlikely that they'll ask to do that, to prove using trigonometry. But let's see. Let's say we have this here. We know this is going to be our 30-degree angle, right? And this side it faces that we want to find will be the opposite. So remember, the side that's opposite the angle that's less than 90 is called the opposite. It's opposite the angle that's less than 90. So this angle is the angle that tells us about the opposite. So when we're using the trig ratios, we'll use opposite along with the 30-degree involved. So this is my opposite. Now, which measurement are we given? We're given this measurement. That's with the 30 and the 90. So this is our adjacent side, right? The adjacent side is next to the 30 degrees because, of course, this is our hypotenuse. But we're not going to use this because we're not given this, and we don't have to find it. So opposite and adjacent will be tangent. So it will be tan theta equal opposite over adjacent. So we can say tan. What angle we're working with? 30 degrees. This is the 30 degrees that tell us that this is the opposite. The opposite, let's call it x. All right. Over an A, the adjacent side is 6 centimeters. And so if we want, because the x is on top, we're going to multiply these two guys here. So to find x, we're going to be 6 tan 30 degrees. All right. Remember, we got 3.5 in our measurement with the ruler. Let's see what our calculator gives us. So I'm going to put in 6, right? 6, and I'm going to press tan. 6 tan 30. All right, and that will give us, okay, now because I don't want this, I don't need to see exactly what that is, so I'm gonna press standard to a decimal, and it gives me 3.464, etc. But remember, this is a ruler, and the ruler don't give all that decimal places, right? So you have to estimate it, and if you should round this off, 3.464, etc. to one decimal place, which is probably, you know, as much as I can get from the ruler itself, it will be 3.5, because this first decimal place here is a 4. When we check the next digit is 6, so we have to add 1 to the 4, so it's really 3.5 if we want one decimal place, which is exactly what we got when we measure it with the ruler. See, from C right down to B, 3.5, because that's between 3 and 4 midway. All right, so x is equal to 3.5 centimeters to 1 decimal place, corrected it to 1 decimal place. But you see how this trigonometric ratio is more accurate. It gives all the decimal places. A ruler wouldn't be able to give us that level of accuracy. All right, so that's how we do it.